All right, this is lesson 5-6. You will learn to use inequalities involving angles and sides of angles. We got a little bit of algebra review here first, and some properties you can use to deal with inequalities. There is the addition property of equality and the multiplication property of equalities. There's also a division property of, I said equalities, but I meant inequalities, and a division property of inequalities. There's also the transitive property of inequalities. All those work with inequalities. Here's an example. You can check that out. Remember when dealing with inequalities that if you multiply or divide, as you're doing it by a negative, you have to reverse the sign. So I'll just do a couple for you and help remind you how you do this. Number one, really we just need to use the addition property of inequalities to add 13 to both sides. And we get 7x is less than or equal to negative 3, then divide both sides by 7, and we get x is less than or equal to negative 3/7. So it's just like solving an equation. Look at number 3 here, and there's an example where we're going to have to reverse the symbol. If I use the addition property of inequality first, then I get negative 2x is less than 21. Then I'm going to divide both sides by negative 2, and I'll show this. But when you divide both sides by negative 2, you have to reverse the sign. Negative 2 divided by negative 2 is 1x, and 21 divided by negative 2 is negative 10.5. I'll do one other one. Let's see, I'll do number 13. Number 13, one thing you can do first is divide both sides by negative 3. If you do that, then you end up with 4x minus 1 is less than or equal to, notice I reversed the sign, and 15 divided by negative 3 is negative 5. Add 1 to both sides, and you get 4x is less than or equal to negative 4. Divide both sides by 4, and you get x is less than or equal to negative 1. All right. So here it is, inequalities in one triangle. Just remember earlier we learned the exterior angle theorem, which says that the exterior angle is equal to the sum of the interior angles. So in this one, measure of angle 4 is equal to the measure of angle 1 plus measure of angle 2. We're going to use that. So the exterior angle for angle 1 would look like this. And that would equal this angle plus this angle. Circle the statement that represents an inequality. Inequalities are things that aren't equal, so that one and that one. Number 6, the symbol that represents each of these, y is less than or equal to z. That's that one. The temperature is at least 80, that means it's more than or equal to 80. Greater than or equal to 80. All right, continuing on. Comparison property of inequalities. If A equals B plus C and C is greater than 0, then A is greater than B. Circle the group of values that satisfies this. The first one does not because C is not greater than 0. C is equal to 0, so we don't want that one. The second one, we can see that A equals B plus C, 5 is equal to 2 plus 3. And so that one satisfies it because A is greater than B. And the last one we have A is not equal to B plus C. 6 plus 1 is not equal to A, so that one doesn't work. All right.
Kim Wondrop, if you are in the building.
All right. A little interruption. Proof of the comparison property, the one we were just talking about. we're just going to fill in the reasons here. So C is greater than 0. You can see that that's given. And what we're going to do next is just add B to both sides. So that's the addition property of equality. Then the next step, we just add the B plus 0, and that's equal to B. That's the identity property of addition. Then we're going to just write down our other given, A is equal to B plus C. And lastly, we are going to substitute for the B plus C, the letter A. So we're putting this, since it's equal to A, where this is, and so we get a new statement, A is greater than B. So that's substitution. All right. So that principle leads to a corollary to the triangle exterior angle theorem. It says that if the measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles. So remember earlier that we said that the exterior angle is equal to those two remote interior angles, so 2 plus 3 is equal to 1. But now, since we know both 2 and 3 are greater than 0, we can say that 1 will be greater than either one of those two angles. So 2 and 3 are both less than 1. And here's a quick proof of this. Given that angle 1 is an exterior angle of the triangle, we want to prove that measure of angle 1 is greater than the measure of angle 2, and the measure of angle 1 is greater than the measure of angle 3. And we will do that by, we know by the exterior angle theorem that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. That's these two added equal that one. Since the measure of angle 2 is greater than 0 and the measure of angle 3 is greater than 0, you can apply the comparison property, the one that we just learned on the previous page. And conclude that the measure of angle 1 is greater than the measure of angle 2, and the measure of angle 1 is greater than the measure of angle 2. All right, so we're going to learn to apply this corollary now. Why is the measure of angle 1 greater than the measure of angle 4? Well, we know that the measure of angle 1 is greater than the measure of angle 3. And that's because angle 1 is an exterior angle and has to be greater than either of the two interior angles. And that's by the corollary. The exterior angle theorem. And we also know that the measure of angle 3 is equal to the measure of angle 4. And that's by the vertical angle theorem. And then, by substitution, we have the measure of angle 1 must be greater than the measure of angle 4. All right? So here's a problem for you. Use the figure out right. Why is the measure of angle 5 greater than the measure of angle C? Go ahead and try it if you want. You should notice that angle 5 is an exterior angle. So that means it is greater than the two remote interior angles, which are 3 and C. So angle 5 is an exterior of angle ABC. And that is by the definition of exterior angles. And the measure of 5 is greater than the measure of angle C by the corollary to the exterior angle theorem. All right, here's theorem 510, theorem 511. If two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. And the related theorem to that is, if two sides of the triangle are not congruent, then the longer side lies opposite the larger angle. All right, we're going to give a proof of this, indirect proof. So given that measure of angle A is greater than the measure of angle B, and you can see that. Given that you have a measure of angle A greater than angle B, we want to prove that BC is greater than AC. So assume temporarily that BC is not greater than AC. In other words, BC is less than or equal to AC. All right, let's look at the first possibility. If BC is less than AC, then the measure of angle A is less than the measure of angle B by theorem 510. This contradicts the given fact that the measure of angle A is greater than the measure of angle B. Therefore, BC less than AC must be false. The second part is, if BC is equal to AC, then the measure of angle A is equal to the measure of angle B by the isosceles triangle theorem. This also contradicts the measure of angle B is greater than the measure of angle A is greater than the measure of angle B. Therefore, BC equals AC must be false also. So the temporary assumption BC is not greater than AC is false. So BC is greater than AC. All right, problem 2, using this, which corner of the triangle plot of land forms the largest angle? Well, let's order these sides in order from least to greatest. So 47 comes first, then 55, then 62. And the sides opposite those angles, opposite 47 is C, so that's the smallest angle. Opposite 55 is A, that one comes next. And opposite B is 62, so that one comes last. So the largest angle will be angle B, because it's opposite the largest side. All right, suppose a landscape architect wants to place a drinking fountain at the corner with the second largest angle. Which two streets form that corner? So let's just label this here so it makes it easier. A, B, and C. And opposite A is 175, opposite B is 120, opposite C is 105. Since 120 is the second largest side, the angle opposite that is the second largest angle, so we'll say angle B, which is the intersection of Hollingsworth and MLK Boulevard. All right, I'm going to pause now, and there's going to be a second part of this video. This is kind of a long lesson.